Okay friends, now we discuss about the next topic of this rotational dynamics is an conical pendulum. Actually you hear this label as an conical pendulum, then you can say that this part is already taken in 11 standards. Yes, this part is already taken in 11 standards, but actually this is an application of a UCM, uniform circular motion. That part use according to that application. Therefore again here we revise that concept and we develop some formulae for that once. Last time we developed only one formula of a periodic time. Now we develop a formula for angular velocity as well as a frequency. Okay, now what is a conical pendulum? What is a conical pendulum? Conical pendulum is an actually simple pendulum. What is a simple pendulum then? What is a simple pendulum? This is an one particle, heavy particle, tied to the fixed support by using an inextensible, massless and twistless string. Then this is called as an ideal simple pendulum. Okay, this is called as an ideal simple pendulum. In case of ideal simple pendulum, here we use a one heavy particle, but this is not possible to use a heavy particles. Okay, then instead of this one, in a practical case, here we use this as a bob, heavy metallic spare, bob tied to the fixed support by using an inextensible and twistless string, because the massless string is not possible. In an ideal case, we use a massless, twistless and inextensible string. In case of a practical, we use only inextensible and twistless string. Then this is called as a practical simple pendulum. And what is a conical pendulum? Conical pendulum is a simple pendulum. Only the difference in between them is the bob describe a horizontal circle. Now observe this one. This is a string and this is a bob. This is called as a simple pendulum tied to the fixed support. Here we say that bob moving along a horizontal circular path, like that once. That bob moving along a horizontal circular path, then the string forms a cone. Therefore this pendulum is called as a conical pendulum. Now here we say that this is an fixed support, this is an fixed support, and this bob moving along a horizontal circular path. This is an center. Here we say that this is an height h, and this pendulum is moving like this one. This is a bob that get moving along the circular path. Radius is an r, height is an h, and length is an l. Angle made by this bob with an vertical is an theta. Then this pendulum, it's called as a conical pendulum. Okay, this is called as a conical pendulum. Then what is a conical pendulum? A simple pendulum in which the bob moving along a horizontal circular path and string forms a cone. String forms a cone. Then this pendulum is called as a conical pendulum. Okay, now we develop the equation for that one. For that purpose, we must know the centripetal and centrifugal concept. You again see that lecture of a centripetal and centrifugal force. Okay, now observe these ones. Which forces exerts on this bob? Here we say that this is an bob whose mass is an m. The first force is an gravitational force, and gravitational force always exerts in downward direction. This is an mg. Another one is that bob tied to the fixed support by using a string. Then due to the weight of this bob, tension get forms. This tension is an T0. This tension is an T0. Tension is T0, weight is an mg, and that two forces exert on it. If we observe this figure, then you can say that they are not along a same line. And if they are not along a same line, which means that here we resolve that vector, then this mg get resolved into two components as A. Now observe this. This is an mg that get resolved into two components as A. This is an one component and another component is a perpendicular to that ones. Or for the simple way, we can also resolve this tension into the two components. We can also resolve this tension into the two components. Okay, then simple or better way is, and here we resolve the tension into two components. This angle is a theta, then we can say that this angle is also theta. Okay, next one's T0 is an vector quantity resolved into two components. The component near to the theta is an T0 cos theta, and the component perpendicular to this one is an T0 sin theta. Clear? Eh? Next one means that T0 get resolved, that get cancelled. This is when vector get resolved into two components. Now that three vectors are present in that case. Okay. If we observe this conical pendulum, then in that conical pendulum, that two forces T0 cos theta and mg get balance each other, because this is on vertical equilibrium position. That bob does not move in an upward direction or a downward direction, which means that the two forces get balance each other. Okay, now here we write that two forces, and that forces get balanced. Then one is an T0 cos theta and another one is an mg. That two forces get balanced. Okay, another one is an T0 sin theta, but there is no any force balancing for that ones, which means due to that one, that pendulum get moving along a circular path. That force along the radius toward the center, and we know that the force along the radius toward the center is a centripetal force, which means that the T0 sin theta provide the centripetal force. Then here we write this as a T0 sin theta provide the centripetal force, and we know the formula of a centripetal force. What is this? Yes, this formula is mv square upon r. mv square upon r. Now here we say that this is an equation number 1 and this is an equation number 2. If we take a ratio of these two equations, then that T0 get cancelled. Sin theta upon cos theta is an tan theta is equal to m and m get cancelled. This is equal to the v square upon r into g. Then what is this theta? Theta is equal to tan inverse of a v square upon rg. This is an angle made by this pendulum with an vertical one. This angle made by the pendulum with an vertical one, theta is equal to tan inverse of a v square upon rg. Okay, next ones. What is a v in that one? If we write this equation like this one, then this v square is equal to the rg into tan theta, or v is equal to the square root of rg tan theta. What is this v? V is an velocity of this bob. This is an velocity of this bob. Also we can find out a angular velocity for that ones. We know the formula of angular velocity, and by using that one we can develop the formula of angular velocity. Then v is equal to r omega. If we substitute this r omega in that ones, then this formula can be written as this formula can be written as r omega is equal to square root of rg tan theta. Okay, now transfer this r to the right hand side, it get divided. Okay, then this omega is equal to square root of rg tan theta divided by r becomes r square. When we transfer this in a square root, then this becomes r square. Now this square and this one r gets cancelled. Or we can write this as a omega is equal to square root of g tan theta. Okay, g tan theta. If we substitute the values of a r in that ones, what is the r? Observe this triangle. This is a right angle triangle. This is an right angle triangle. If we observe this one, then this right angle triangle is like this ones. This is an L, angle theta is there, and this is an r. Then what is the value of a r? Then this sin theta is equal to the opposite side divided by hypotenuse, r upon L. Therefore r is equal to L sin theta. And now here we substitute this r is equal to L sin theta in that one, g as it is. What is the tan theta? Tan theta is an sin theta divided by cos theta divided by, instead of the r, here we write this as an L sin theta. Now observe this ones, instead of the tan theta, here we write this as an sin theta divided by cos theta. Okay, then this g as it is, this is an tan theta, and instead of the r, here we substitute L sin theta get cancelled, omega is equal to square root of g divided by L cos theta. Okay, then by using that omega means angular velocity, we can find out the value of a angular velocity of this pendulum. Okay, if the numerical is an asked in an example, find the angular velocity of this bob, because this bob get moving along a circular path, then it has angular velocity, and its angular velocity can be found out by using this formula. Okay, next ones, this bob performs a circular motions, then it has a periodic time t is equal to 2 pi divided by omega, and if we substitute omega in that one, then this is equal to the 2 pi divided by square root of g upon L cos theta, or periodic time t is equal to 2 pi square root of, transfer this one, L cos theta divided by g, means this is a formula of a periodic time of a conical pendulum. By using that formula, we can find out its periodic time. What is the L? L is a length, and we know we can easily measure that length. G, acceleration due to gravity, constant terms, pi is a constant, 2 constant. Only if we know the theta, then we can find out its periodic time. Means, suppose this is a conical pendulum, angle made as an very small, then we can say that theta is an small, and if the theta is small, then its cos theta is an greater. Okay, like that once, if we can find out its periodic times, then according to the value of a theta, its periodic time get changes. Okay, next ones, we can also find out its frequency. We can also find out its frequency. What is a frequency? Frequency n is equal to 1 upon t, means only take a reciprocal of this periodic time, then we can find out its frequency. Means number of revolution completed in a 1 second. How much revolution completed by this conical pendulum in a 1 second, that can be calculated by using this formula. N is equal to the, instead of the t, if we substitute this one, means here we take a reciprocal of this equation as a 1 upon 2 pi square root of g divided by L cos theta. Means by using that equation, we can find out its frequency. Means this is a formula for the frequency of a conical pendulum. Then observe all the formulas. This is on first, means to find out a angle made by the pendulum with and vertical one. This is on second, means we can find out its linear velocity by using that formula. This is on third, we can find out a angular velocity. This is on fourth, we can find out a periodic time, and this is on fifth, we can find out a frequency of the conical pendulum. Also, there is another method to solve this equation. Only substitute the mr omega square, means this is centripetal force formula. This is an mv square upon r is a formula of a centripetal force. Another formula is mr omega square. We can directly find out this omega by solving these ones instead of the v. Okay, we can directly find out omega in that case. This is also another method to solve these ones. Like that way, we can develop the formulae for conical pendulum like this ones. This is a concept of a conical pendulum. This is an application of a UCM. Okay, this is an first part. Now, we discuss one more applications, and on that application, one examples or one numerical is an asked one. Which examples is this ones? If we moving on a road and if there is a speed breaker on these ones, if the vehicle moving with and some greater velocity, then that vehicle get jump on this speed breaker on this curve path. Then what is an velocity with which that vehicle can be easily transferred from this speed breaker without losing a contact with this road? and here we find the value of this velocity. Okay, now observe this case. Okay, the second case is like this one's vehicle moving on a curve path, or we can also say that this is an concave bridge. Okay, concave bridge. This example also say that this is a concave bridge, vehicle moving on a concave bridge. Then what is its velocity with which it can be moving without losing a contact with this road? Okay, observe this concept. Here we say that this is an road. Okay, next ones, this is an speed breaker, or we can say that this is an concave bridge. And vehicle get moving on this one. Suppose here we show this vehicle is a very small one, like this ones. Here we show this vehicle. Its mass is an m. Okay, its mass is an m. Then the gravitational force exerts on this vehicle, and this gravitational force is an mg. Gravitational force is an mg. Another force exerts on this vehicle. This is in center. Okay, another force exerts on the vehicle is a normal reaction, because this vehicle is in contact with the surface, and we know that if any body is in contact with the surface, then the normal reaction exerts on it, and this normal reaction exerts on the vehicle by the road is perpendicular to the surface, like this one. This is a normal reaction. Means that two forces exerts on the vehicle. One is a gravitational force, another one is a normal reaction. Okay, next ones. If we develop the equation for that one, this is an mg and this is an n, both are along a same line, and that two forces n and mg, the two forces provide the centripetal force. Now here we say that centripetal force is toward the center, means mg is greater. Then this mg minus n is equal to centripetal force mv square upon r. If that centripetal force exerts on this one, then and then only that circular motion is possible. Okay, and that provided by these two forces. Means that equation can be written like this ones. Now observe this ones. Question is, how much velocity of the vehicle with which that can be drive on this curve path without losing a contact with the road? Okay, now here we say that its velocity is greater. If its velocity is greater, then the maximum centrifugal force exerts on this one, and that vehicle get moving away from the center. Okay, last time we already discussed about that centrifugal force. If that velocity is greater, centrifugal force is greater, then that vehicle get moving away from the center. Okay, then there is a losing a contact with the road. Now here we say that this vehicle just contact with a road, then we can say that just contact means there is no any force exerted by this road on this vehicle. Actually gravitational force exerts, but there is a just contact with a road, which means that no any force exerted by the road, which means that normal reaction is equal to 0. Okay, again listen. This vehicle just contact with the road, which means that less force or no any force exerted by this road, then normal reaction becomes 0, and if the normal reaction becomes 0, then this mg is equal to the mv square upon r, or m get cancelled, or we can say that v square is equal to rg, or v is equal to root rg. Then how much velocity of this vehicle? This velocity is v is equal to root rg. If that velocity is greater than this ones, then that vehicle does not contact with the road. And if that velocity is this is an equal to or less than this one, means this is a maximum velocity. This is a maximum velocity. If that velocity is less than or equal to these ones, then and then only that vehicle is in contact with the road. And if it is greater than this one, it does not contact with the road, that gets jump on this road. What happens? That get jump on this road. You already observed that once. कधी कधी असं होतं, तुम्ही गाडी चालवताना तुमचं लक्ष नसतं, स्पीड ब्रेकर आहे किंवा स्पीड ब्रेकर दिसत नाहीये, अशा वेळेस आपण जास्त वेलोसिटीने स्पीड ब्रेकर वरून गेलो तर व्हेकल काय होत असते, आपली गाडी काय करते, जंप करते. का बरं जंप करते? बिकॉज दॅट वेलोसिटी इज ग्रेटर दॅन दिस वन्स. Means how much maximum value is there? This is an equal to root rg. What is the r? R is the radius of this curve path. And what is the g? G is an acceleration due to gravity, and g cannot be changed. G cannot be changed. Only we can change this r. R get changes, then that V can be changed. म्हणून तुम्ही ऑब्झर्व केलं असेल, ज्या वेळेस हायवे असतात ते अशा वेळेस स्पीड ब्रेकरची रेडियस आहे ती जास्त ठेवली जाते. कर्व पाथ घेताना इज लाईक दिस वन्स, दिस कर्व पाथ लाईक दिस वन्स, means that radius get increase. आणि जर छोटा रोड असेल, तुम्हाला स्पीड खूप कमी करायचं असेल, जास्त ठेवायचंच नसेल, तर तुम्ही ऑब्झर्व केलं असेल स्पीड ब्रेकर असं असतं. ओके, स्पीड ब्रेकर जागेवरच असतो एकदम, म्हणजे त्याच्या केसमध्ये सेंटर इथे येतो आणि त्याची रेडियस कमी, Vmax कमी, म्हणजे तुम्हाला गाडीचं स्पीड जास्त कमी करावं लागतं, नाहीतर गाडी जम्प करते त्याच्यावर. ओके, हा प्रॉब्लेम. हायवेला काय असतं, गाडींचं स्पीड ऑलरेडी जास्त असतं आणि ते खूप जास्त कमी करता येत नाही, म्हणून अशा वेळेस त्यांची स्पीड ब्रेकरची रेडियस ही जास्त ठेवलेली असते. ऑब्झर्व दॅट कन्सेप्ट. Okay friends, then there are two points. One is a conical pendulum and this is one small case here we take because that case is asked in a numericals. You observe that questions in and different MCQ books. The questions are depends on this one. What is the Vmax? Root Rg, and there are 5 formulas for the conical pendulum we develop in that ones. You observe that video again and write the notes in your own notebook. Okay, thank you.